Hello everyone. So welcome to the second day of Python session. I hope I am audible. So in the yesterday session, we had discussed about like Python introduction, which is what is Python, why it is so popular, features of Python, how to install it, and how to install it and how to install it IDE, etc. Now in this session, we are going to discuss about Python fundamentals, especially Python tokens, keywords, identifiers, and literals or data types, or some of Python operators. Okay, so let's start. So here we have keywords, sorry, Python tokens. Yeah. So here we have Python fundamentals, where we have Python tokens. Now, what are Python tokens? Python tokens are the smallest individual unit in Python program, which means everything in Python is a token. Okay, think of a like a human body. So in the human body we have cells. So cells are the building block of humans. Same as we have tokens. Tokens are the building block of in Python. Basically, they are not important, but it is you can just know it. Okay. So we have tokens, which is like the smallest unit in Python, which is like everything is in Python are tokens. Okay, then we have this one, which is character set, which is also not that much important. So yeah, so we have this character set. So in the character set, we have like what kind of characters are allowed in Python. So basically, we have this one alphabets, which is A to Z, small case and uppercase, digits, and here we have some special symbols, and then we have this white spaces and underscore. Even you can use emojis in the form of encoding. Okay, so these kind of characters are allowed in the Python, which is casual or genuine, you all know. So then we have tokens and then we have keywords. Now inside tokens, we have keywords, we have identifiers, we have everything. Okay. So in what are keywords? Keywords are the special words for the Python, which have like a special meaning for the Python. Okay, we can say they are the reserved words. For example, we have print, we have true, false, none, elif, if else, statement, for loop, while loop. So these are the special keywords, okay, which have special meaning for the Python interpreter. So here we have keywords, okay, and you cannot use keywords names as a identifier, which means you cannot use keywords as a variables or as a function names. Okay, so those are known as keywords, which have special meaning for the Python interpreter. For example, these are the keywords. Then we have identifiers. Identifiers are the names which are given to any of the variables, any of the function, or any of the class, or methods, or module. Okay, so whatever you are naming, you are naming any variable, you are naming any function, you are naming any class or any object. So that is known as identifier. Okay, and identifiers are case sensitive. Okay, as I said, variable names or we can say functions, these are case sensitive. So identifiers are the names given to any variable, any function, any class, any kind of data type, any methods, etc. Okay, for the identification. Then we have, now these are, as I said, these are case sensitive. So these are some common rules of the identifier. Okay, as I said yesterday, these are known as naming conventions. Okay, like a variable cannot start with the number. They can start with the uppercase or lowercase. Then we can use underscore and we cannot use any special characters. Okay, so these are some naming convention which we have discussed yesterday. Now we have literals or we can say values. Okay, now what are literals and what are values? For example, we have this one variable a equal 1. Now this a is a variable, but what is this 1? 1 is a value. Okay, now data type is kind of a value which define what kind of value you are storing inside a variable. Okay, so this one is a data type, or we can say a value, simple. So data type we can say, or you can say literals. Basically, no one use literals, but you can just keep in mind. Okay, so literals are nothing, they are just data types, or what kind of value you are storing inside a variable. So again, we have data types like we have string. Okay, strings are anything you are enclosing inside quotations, like single quotations, double quotations, and triple quotations. For example, we have this computer science. So this is a string. Sam, this is a string. Okay, even we can use triple quotations in the strings. Then we have character literals, which is also strings. Okay, so basically string literals and character literals, they are all same. They are string data type. Okay, so in the character literals, we have this one, any character like any number or any special character. So they are also strings. Okay, so anything you are enclosing inside quotations are known as string. It can be any character, it can be any alphabets, it can be the combination of alphabets, or it can be any number. Okay, so if you are enclosing any number inside the quotations, they are also known as strings. Okay, so basically, these are data types. Okay, so we have this string and character. So they are all string data type. Then we have numeric. Inside numeric, again, we have three types, integer, float, and complex. Okay, so let me mention here. So here we have strings. Then we have numeric. Inside numeric, we have integer, float, and complex. Okay, so integer is any number. Then we have float, which is decimal numbers, and complex combination of alphabets and numbers. Okay, then we have boolean, which is contains two values, true and false. Okay, which is known for bool. Okay, we have boolean value, which is bool, which contains two values, true and false. Okay, now then we have special literal, which is known as none. None means no value, or like absence of any value. For example, if you want to create any function or any variable, let's say a equal, and in at this time you don't want to store any value, then you can use none here. Okay, and make sure n should be capital letter. Okay, a means none. Now a is like a variable which contains no value. Okay, so we can also use a equal, like we cannot leave this variable empty. Okay, this will throw an error. So if you want to store anything but not right now, so here you can use none. Simple. Yeah, tuples are also a data type. Then we have literals collections. So in this, we have some more data types, which are, first we have list. Okay, then we have tuples. Then we have dictionaries. And then we have set. And then we have frozen set. Okay, so we have these data types. Now, strings, this one. Strings, or we can say these types of data type can only store one value at a time. Okay, but here, list, tuples, dictionaries, set, and frozen set, they can store multiple values at a time. Okay, so let me mention here. Data types which can store. Okay, so these are the data types which can store multiple values at a time, like list, we have tuples, we have dictionaries, set, and frozen set. Okay, although they are all data types like string, numbers, and boolean, these are all data types in Python. Okay, the only one and only data types. So we have discussed strings, numeric, and boolean. Now in this session, we will going to discuss about list, tuples, dictionary, set, and frozen set. Okay, and before that, we have some operators in Python. Okay, for example, let's say we have this operation 2 plus 3. Now 2 and 3 are known as operand, and plus is here operator. Okay, so here 2 and 3 are operand, means values, and plus is an operator here. So same in Python, we have many operators. We have arithmetic operators, we have assignment operators, comparison operators, and so on. Okay, that we will see later sessions. So here, the variables on which operation is applied are known as operands. Okay, and this plus, minus, or any other operator are known as simple operator. Then we have punctuators, which is you can think of a grammatical uh, syntax of Python. Like here we have parentheses, we have square brackets. These are known as grammar of Python. Okay, like grammar of Python language. So here we have this curly braces and square braces. These are known as punctuators. Okay. Then here we have Python operators. These are the Python operators which we will see in the later sessions. Now we have these variables which we have already discussed. So variables are the containers for storing the data values. For example, here x equal 5. So x is a variable, 5 is a value, and this equal sign is a assignment operator. Basically, we are assigning 5 value to a variable x. Same as John. John is a value here, which is a string, and we are assigning this John value to a variable y. Okay. And then here we have some variable rules. Okay. As we have discussed yesterday, so a variable name start with the letter, okay, not with any number. Okay, letter and underscore. Letter can be uppercase or lowercase. Then it cannot be start with a number, but numbers are allowed. Okay. Then you can use any character. Uh, you cannot use any special character. You can use only underscore. Okay, even spaces are not allowed. Then variables are case sensitive. So while naming your variable, make sure your variable name should be meaningful. For example, let's say you are storing a name. Okay, let's say name equal any name. Okay, so here now if anyone reads your code, they will know, okay, name is a name variable which is storing a name value. Okay, if you are storing like x or let's say a equal any name, okay, so this will confuse the reader. Okay, because if you are coding, let's say you are coding, so coding is not enough. Okay, like how you code, that matters. Okay, so basically, always make your variable name meaningful. Okay, or we can say it will depend on your value, what kind of value you are storing. Now, then we have this one multi-variable names. Like you can use these cases to name your variable. So we have camel case, we have Pascal case, or we have snake case. For example, in the camel case, you can use like full name. Okay, like second word should be uppercase. Then you can use Pascal case like full, then name like this. Or you can use snake case, full underscore name. So you can use any of these cases to name a variable. Okay. You can use snake case or any other name. Mine is, I always use snake case. So it depends on your, like how you code. So you can just choose any of the case. Then we can also store multiple values to multiple variables at the same time. For example, here we have three variables, x, y, z. And here we are storing three values, which is orange to x, banana to y, and cherry to z. Okay, then let me show you. So we can open the VS Code. Okay, yeah. So here we can use x, comma y, comma z equal. And then we can mention the values. Let's say a, comma b. You can even store numbers. Okay. Now we can print x, comma y, comma z. Okay, all together. And if you run this one, yeah, you can see ABC. So here we are assigning a variable to x, b to y, and c to z. Also, you can do like this one, which is a equal, sorry, a is a value. We can use anyone. Let's say x equal y equal z equal, and you can mention the value. Let's say any value, apple. Okay, and let's print XYZ. Okay, so here we are assigning apple value, a single value to XYZ variable. Okay, so you can also use this method also. So basically XYZ contains same value apple. Okay, or you can do like this one. You can use three variables and you can assign multiple values at the same time to multiple variables. Okay. Then we have this one. Okay. So we have this one. Now we can move to the data types. So here we have this data type known as list. Okay. So now what are list? First, we can write the features of the list. So list can store multiple values. Okay. For example, let's say we have this one fruits equal, and we can mention, we can use square brackets for the list. And then we can mention the name of the fruits. Okay. Then we can simply print fruits. Right. So first, list can store multiple values. For example, here you can see, for example, you have this variable fruits. Okay. Now here you want to store multiple values. Now you cannot use string for that. Like for example, you are using apple here, comma, and here you are using cherry. Okay. Now this is not possible. Okay. So if you want to store multiple values to a single variable, you can use list here. So here you can simply use square brackets. Okay, like this. Here you have apple and here you have cherry. Now we can simply print fruits. Okay, now we can save it and you can run it. So here we have this apple and cherry inside list. And if you check the type of this variable, which is fruits, okay, like this one, then you can simply run it. So you can see it is a class list. Okay, so it is of type list. So this second point here, which is list always enclosed inside square brackets. Okay. Now we can store. Now let's list our order in nature. Okay. They are ordered. Then we can say they are mutable in nature, which is we can change it. Then it can also allow duplicates values. Okay. Now what is order? Uh, yes, they also has indexing as well. So first, what is order? Let me show you. For example, we have multiple items in this list. Okay, let's say we have apple, cherry, and we can mention some more items like A, comma B, like this one. So when you run this, when you print the fruits, you will notice they are in the same order. Like we have first apple, here also we have first apple, then you have cherry, then you have cherry. So whenever each time you run this one output, you will get the same order, in the same order. Like we have apple, we have cherry, we have A and B. So that is why lists are order in nature. Second, they are mutable. Mutable means they can change. Okay. Now change means you can add, you can remove, and you can change the items of the list. For example, like you can add any other value in the list, you can remove any value, and you can change any other value in the list. For example, after creating the list, you can add any other value. Okay, you can use fruits dot append, and you can mention what kind of value you want to append. Let's say C. Okay, and when you run this one, You can notice we have, sorry, let me run this. Okay, now you can see we have apple, cherry, and A, B, C. So basically, we can add value, we can remove value, and we can change the elements of the list. For example, in place of apple, I want any other value. So you can easily change it. Okay, how to change? That we will see. But for an example, let me show you. If you want to change it, we can simply use fruits, and then we can use the indexing of the list. Now, what is indexing? Indexing are like you can think of a roll number for the elements of the list. So here we have apple. Apple is an element, or we can say item of a list. Cherry. Cherry is an item of a list. A is an item of a list, and B is also an item or element of a list. Okay, and this is one list. Now here we have this indexing. Indexing, as I said, a kind of a roll number for each and every element of your list. Apple is a element which have indexing 0. So it starts from 0. So we can mention here indexing starts from 0. Okay, so for example, we have this apple. Apple index is 0, cherry is 1, and orange is 2. Okay, now here I want to change apple to any other value. So you can mention the index of this apple, sorry, of this particular element, which is 0. Okay, if I print this value, let me show you. Okay, so basically we are printing fruit. Fruit is a list, and 0. 0 is your value. Okay, sorry, your index. So when you run this, you will get apple here. Okay, because in 0 index, we have this value apple. Same as if I apply 1, so you will get cherry. Okay, and so on. Like if I use 3 here, sorry, 3, and if you run this one, you will see B here, because 0 is apple, 1 is cherry, 2 is A, and 3 is B here. Okay, if you apply any other index, let's say 4, so this will throw you an error which is out of index. Okay, which is index out of range, because we have only 4 elements: apple, cherry, A, and B, which is 0, 1, 2, and 3. Okay, so now what we can do, if we want to change any of this element in the list, then we can simply use fruits. Okay, we can mention the name of the list. Then here we can mention 0. So I want to change apple to any other value, and here we can use D here. Okay, and if you print the fruits, okay, so here we have D, which is in place of apple. Then we have cherry, A, and B. Okay, so this is how we can change. Okay, we will see all the operations and methods of list in the later sessions. But now lists are mutable in nature. We can add value, we can remove value, and we can change the elements of the list. Okay, that is why they are mutable in nature. Then we have list can also allow duplicates value. For example, here you can mention 111 like 3 times, or any other value you can mention here. Okay, 4, 5, 6, and you can mention duplicates value. Okay, so if I remove this one, uh, if we print the fruits, then you will see the duplicates value as well. Okay, like we have apple, cherry, and here we have 1, 2, 3, then we have 1, 2, 3, then we have 6, 4 times. So basically we can also like duplicates values are also allowed in the list. Now we can also store any other data type inside list. Yes. So we can also mention we can also put any type of data type inside list. Okay, for example, let's say we have this list, we have apple here, we have cherry here, we have strings here, then we have integers here. Okay, then we can also mention here floats. any value. So we can mention floats. We can also mention Boolean values, which is true and false. Okay. And then we can also mention complex numbers. We can also mention list inside list. Okay, for example, here I am creating another list. Okay, and here I can mention any value again, a 1, 2, 3, 4. So here you can see we have this one. Here these are strings, these are integers, this is float, and this is Boolean values. And this one is a list, which is list inside list, which is known as nested list. Okay, so if I run this one, sorry. Okay, so here we have these strings, integers and floats and booleans, and here we have this list. So here we have list inside list. Okay. Again, we can store any type of data type. We can store tuples inside list. We can store dictionaries inside list. We can store set inside list. So we can store any kind of data type inside list. Okay. So these are list. So let's take a recap of the list. List are a data type which can store multiple values at the same time. Then they are enclosed inside square brackets. Okay, they can store any number of data type, any type of data type. Then they are ordered in nature, they are mutable in nature, and they can allow duplicates value. And the indexing start from 0. Okay. So now let's move to tuples. Now, what are the features of tuples? First, again, they can store the, let me copy this. Yeah. So we have tuples. They can also store the multiple values. They are enclosed inside parentheses, which is known as round brackets. Okay, so these are round brackets. And here we can mention round brackets. Okay, also they are order in nature and they are immutable. Okay, now immutable means unchangeable. Okay, like you cannot add, remove, or change any of the item inside tuples. Okay, that is why they are immutable in nature. Then we have, they can also allow duplicates value. Also, they have indexing which starts from 0. Okay, and again, we can store any other data type inside tuples. Okay, so let's see. So again, we can create a tuple, let's say x equal, and we can use parentheses here, and we can store values. Okay, like 1, 2, 3. Okay, spaces are not necessary. So let me remove them. Now, if you print x, okay, let me run this one. So this tuple here, and if you check the type of this x, here we can mention type. Okay, so this is tuple here. So tuples are immutable in nature, which means we have a limited number of methods and functions for the tuples. Okay, that we will see in the later sessions. So we have this print and type x. Again, we can store any kind of value inside tuples. Okay, like you can use parentheses here. Let's say we can use number here. We can use float here. We can use booleans here. We can use any string here. Again, we can use list inside tuples. Let's say a comma b, like this one. So here I'm storing the integers, float, boolean, strings, and also list. Even you can also mention here tuples. Okay, like tuples inside tuples. 1, 2, 3, like this. And simply you can print the y. Okay, here you can see we have these integers, float, booleans, strings, and here we have this list, and this one is tuple. Okay, so basically you can store any kind of data type inside tuples. Now, yeah. Then we have dictionaries. So again, dictionary can store multiple values. Basically, dictionaries are the combination of key value pairs. Okay. And they are enclosed inside curly braces. Okay. Like this one. For example, let's say we have again, let's say X equal dictionary. And here we can use curly braces. Then here we have key value pairs. For example, first here we have name. Okay, name is a key here. Then we can mention the value. Then we can put comma. And then we have age. Okay, another key. And then we have value. Okay, so let me show you here. So here we have this X is our dictionary, where name is a key separated by a semicolon. And this one, John is a value here. And this one key is separated by a comma here. Okay, then we have this another key, which is age. And then here we have 12. 12 is a value here. And if I print the X, okay, so here we have this dictionary. This is how we can create a dictionary. So dictionaries are the combination of key value pairs. So name and age is a key here, and rest 12 and John is a value here. Okay, now we can store any kind of like values inside dictionaries. Okay, for example, we have this names here, or let's say nums here, numbers. Okay, now here you can create like this one. So here we have this numbers, and here you can mention numbers here. Let's say now here I am using list as a value. For example, 1, comma 2, comma 3, like this. So this one is a one key value pair. Nums is a key, and this list is a value of single key. Then we can use names here. Okay, and then here we can use any name. Let's say A, comma B, and so on. Okay, now this is dictionary. Even you can put dictionary inside dictionary. For example, you can put comma again here, and here you can put here scores. And here now I am using uh, dictionary as a value. Okay, now you can use any value here. Now this is a key, and this is a value, comma. This is a key, let's say, and this is a value. Okay, now if I print this Y, so first here we have this numbers. Okay, this is a key, numbers is a key, names is a key, and scores is a key. Okay, then this list, this is a value of nums, which contains three other elements. Then here we have names, which contains string inside list. Then we have scores. Inside scores, we have another dictionary. Okay, so basically it is a nested dictionary where we have this maths as a key, 12 is a value, English is a key, and 90 is a value here. Okay, so this is how you can store multiple values inside dictionary. Now, how we can access the values of these numbers or this keys of value. So, for example, if you want to get the keys of dictionary Y, like only keys, then simply you can use this print Y dot keys. Okay, and if you run this one, so you will get keys only. Okay, dictionary keys, nums, names, and scores. These are keys. Same goes with the values. If you want to get values of dictionary Y, then here you can simply use print Y dot values. Okay, so if you save it and run it, so here we have values, only values. So this is value of nums, names, and scores. Okay, this is how you can get values. And if you want to get items, then you can simply use print y dot items. Okay, and parenthesis. If you run this one, you will get items. Okay, like everything. We have this one numbers, we have this names, and here we have this scores. Okay. Or if you want to get any key of any value of any particular key, then here you can use print. Now let's say I want the key of value of scores. Okay, only value of scores. Then you can mention y. Okay, and then square bracket and name of your variable. Key. If you save it, if you run it, then you will see you will get the value of that specific key, which is this dictionary. Okay, this one. Same as you can change the key name here, let's say nums, and you can run it. So here we have 1, 2, 3. Okay, same you can apply with the x here. We have this x, and you can mention your square brackets and age. Now here you will get 12 here. Okay, so this is how you can fetch the keys, the values, the items, and the specific value of specific keys. Okay. Now, dictionaries are also mutable in nature. Okay, means you can add values, you can remove values, you can change the items of the dictionaries. Okay, so they are mutable in nature. Then they also allow duplicates values, not keys. Okay, so make sure here they can allow duplicates value, but not keys. Okay, and they are also order in nature. Yeah, iteration is possible in the dictionaries. Okay, so these are the characteristics or features of the dictionary. So let's take a 10 minutes pause. So any other questions? Any questions or any doubts? If anyone has any questions, then you can raise your hand, okay, and ask your questions.
Hello. Hello. Can you hear me?
I think you are not audible. Please check your mic.
Hello.
Okay, what kind of complex structures? Yes, we can have. We can add any number of data types in the list. So looks like no one has any questions, but I have one question for all. Okay, so tell me, strings are immutable or mutable? So are strings mutable or immutable? Mutable. Okay, okay, mutable. Any other option? Basically, strings are immutable in nature. Okay, let me prove it. They are immutable. For example, let's say I have this string a equal, let's say apple. Okay, now this string, as you said, they are like mutable in nature, but they are immutable. For example, let's say if I want to change a to b. Okay, for example, here we have this a and here we have this 0 index. So let me print this one. So now what is the index number of 0? Sorry, value of 0, which is a here. Okay, because indexing start from 0. So 0 is a, p is 1, second p is second, and l is 3, and e is 4. Okay, now here, let me comment this one. Yeah. So if I run this one, we have this a here. Now if I want to change this value of a, okay, so let me change it a, and here we can mention 0 equal. Let's say I want to change b here. Okay, now this will throw an error. If I run this one, okay, which means this will throw an error. So here we cannot change the values, right? We cannot change values. What is the meaning of mutable and immutable? In the immutable, we cannot change the values, means the elements of that particular data type. Okay, like here we have strings. Now A is a element of this whole string. P is a element, a single element. Okay, a single character means a element. So basically, immutable means we cannot change the data type, sorry, the elements of the data type. We cannot add any element and we cannot remove any element, which means that is string is a immutable. Okay, if you try to change any of this element, you cannot. Okay, so that is why strings are immutable in nature, not mutable. In the mutable, you can change values, you can change elements, you can add elements, you can remove elements. At least you can change it. Okay. But here we cannot do anything. We cannot add, we cannot remove, and we cannot change. Okay. So that is why strings are immutable in nature. No, this one, let me copy this. This is not, we are making changes in the string. Here we are overriding a variable. Overriding a variable is different from changing a particular variable. Okay. So here you can see the difference. In this particular variable, in this particular operation, we are changing the variable, right? Sorry, we try to change the element of any particular string. But here you are overriding. Overriding simply is possible. Okay, you can simply override. That is possible. But you cannot change this pre-existing values. Okay, you cannot change it. Okay, without creating a new variable. So that is the whole meaning of immutable. Okay. So that is why strings are immutable in nature. Now, one more question. Set. Are set mutable or immutable? Okay, set are immutable. Okay, immutable. Okay. Any other answers? Mutable. So basically, set are no one is right or no one is wrong here. Set are both mutable and immutable. Now, how this is possible? See, set first. Let me write here the features of set. So they can store multiple values. Okay, they are unordered in nature. Okay, that I will show you in a bit. Now, set are immutable and mutable both because let's say we have the set here a equal, and now sets are enclosed inside parentheses. Okay, like sorry, curly braces like this one. Okay, now let's say I want to store something. Let's say 1, 2, 3, 4. Now, how sets are mutable and how set are immutable? So basically, set are mutable in case we can add item and we can remove item from the set, but we cannot change item. Okay, so in the mutable state of set, we can add items or we can remove elements of the set. But in the immutable state of set, we cannot replace or you can say change the values of the items. Elements or items. Okay, anything. So for example, in the immutable, for example, we have 1, 2, 3, 4. Now this set is immutable because here you cannot replace 1 with any other set for any other value. Okay, same as we have 2 here. You cannot replace 2 with any other value. So which means set are immutable. But you can add any value here and you can remove any value in this particular set. So hence, set are both mutable and immutable in nature. Okay, so let's say we have another set, let's say fruits, okay, which are inside curly braces. How we can remove an entry that we will see in the in the later sessions. Okay, like how we can perform multiple operations with our data types that we will see. Okay, for now, let's say we have this fruits here, and here we are storing some values. Okay, now here we have this apple, we have this cherry, and we have this orange. Now, immutable means we cannot change the values of this apple or this cherry or this orange in this set. But we can add any other value or we can remove any of these value from the set. Okay, so set are immutable and mutable both in nature. Okay, then set are unordered. Let me show you this one. So let's create a set 1 equal. We can use curly braces and we can put some values here. B and C. Okay, and then, sorry, then we can print this particular set 1. Okay, and if I run this one, you can see we have this BAC, but my set is ABC, but it is printing BAC. And when you run this again, the order will change, CAB. So that is why these set are unordered in nature. If you again, sorry, yeah, unordered in nature, ACV. So every time you run this set, you will see the elements are shuffled. Okay. So that is why set are unordered in nature. They are both mutable and immutable. So we can mention uh, it is both mutable and immutable. No, indexing is not possible. Good point. Indexing is not possible in the set. So no indexing. Also no duplicates allowed. Okay, so duplicates are also not allowed in the set. Let me show you. So here we have this ABC. If I mention here 1, comma 1, comma 1. So you will see we have only one. Okay, like A1CB, which means no duplicates are allowed, no indexing, and they are all unordered in nature. And they are like mutable and immutable both. So these are the features of set. Even if you check the type of this particular set like this, then you will see they are this is set like class set. And again, you can store any number of data type inside set like list, tuples, dictionaries, etc. Then next we have frozen set. Now with this nature of set, which means set is both mutable and immutable. So that is why we have frozen set. Frozen set is fully immutable. Okay, if you check it here. Now how to create a frozen set? So here you can just mention frozen set like this. And if you check the type of this set 1, you will see this is a frozen set. Sorry, you have to use curly braces. Okay, so this is a frozen set. So just mention this frozen set and then this your set. Okay. So frozen set is like fully immutable in nature, no mutable type. So that is why we have frozen set. Just to make this set fully immutable, that is why we have frozen set. And all the other features are same. Okay. So here we have these data types. So I hope this much is clear. Now we can move to input and output in Python. Now, what is this input and output? So let's say print. You are printing something. Okay, let's say hello. So this is you are printing the output. Okay, that we all know. Now, what is input here? Use case of set and frozen set. Well, it depends on your scenario. For example, you want to create a application where you let's say you want to create any application and you are taking input from any user. Okay, and you want that the user cannot able to change the values of the pre-existing elements, but they can add any value or they can remove any value that you can do. Okay, it depends on like think of a example of a user privileges. Okay, like for example, you are working in a company and there's a database. Okay, and here you have admin here, and then here you have any student here or any student. And let's say there's a feature of uploading file and removing file. Okay, and not changing the pre-existing file. So there you can use set there. Okay, or any other like set is like it depends on your use case totally. So whenever you don't want to change any pre-existing value, and if you want to add any value or remove any value, then you can use set. Okay, frozen set is common. Like you can use when you don't want to do any kind of operation with your pre-existing set, then you can use frozen set. Like for example, again, you can if you don't want to add any value or remove any value by any particular user, then you can use frozen set. Okay, yeah. Then we have this input output. So here how to take input from the user. So here you can use let's say name equal. Here you can use input and then you can mention your input operation, like let's say enter your name. Okay, like this. Let me copy this. And here we have this one. Name equal input, enter your name. And here we can use print name here. Okay, now how to run this? You can simply go to your terminal here. Yeah. So we are inside this folder. We can move on desktop. And then here you can use Python and name of your file hello.py. Now enter your name. So we can enter the name and this will be printed. Okay, simple. So this is how we can take input from the user. Name, input, enter your name. Same as you can use last or let's say age equal int, sorry, let's say last underscore name equal input and let's say enter. Even you can just leave this empty as well. Okay, no need to put anything. You can leave this empty and here you can mention last underscore name. Okay, here we have this name. Yeah, now here this will not work when you click on this particular button. Basically, in my case, it is not working. Maybe this will work in your case. So that is why I'm running this from the terminal. Okay, so Python. Now we can mention the name and last name. Okay, so you can also, it's your choice. If you want to put anything, you can put like whatever you are asking from the user. So here we can use enter your last name. Okay, and here, okay, so you can mention the name. Okay, and you can, and this is how you can print it. Now, if you want to print, you can concatenate. You can use name here. Sorry. Okay, like this name and last name. And you can simply clear the screen. So you can mention the name and last name. Okay. Yes, we can take numbers, but let me show you that one also. So here, let's say you want to add two numbers. Okay, add two numbers. Right. So here, you can use num1 equal. If you take input as a number, then you can enter here, enter first number. Okay. And same as you can use enter second number. Then you can print num1 plus num2. Okay, now we can simply run it like this here. Now first number is let's say 2 and 3. Now you can see we are concatenating the string. Like we have 2 here, we have 3 here, which means this input is taking input as a user, like as a string, which means this 2 is a string plus this 3 is a string. And that is when you concatenate the string, we have answered 2, 3, not 2 plus 3, right? So which means your input is taking, this input function is taking input as a string, not as a number. So basically you have to convert this 2, which is a string, into numbers. So here you can simply put int here, int and then input like this. Okay, same as with this. Here you can put int and input. And if you run this one, 2 and 3. Sorry, 2, 3 plus 2, 25. Okay, so this is how you can take input from the user, like your first number and your second number, and num1 plus num2. So here you can also mention float here. If you mention float, and here as well, float. Okay, and if you run this, so first number and second number. So automatically this will like give output as a float, which is 5.0. So you are converting your one data type into another, and that process is known as typecasting. Okay. So what is typecasting? Which is changing one data type into another. Okay. For example, here, let's say here we have this one A equal 1. So now 1 here is a string. Now you can change it. Okay. Here you can use B equal, or you can simply mention A equal int of another A. Okay, which is previous A. And if you print this A here, or simply we can print the type of A. Okay, to check. So if you run this file, you will see it is a class int. So previously it was string. If you same do here, and you can change B here. Okay, 1 second. Yeah, B here. So first we have this A here, and here we are checking the type of A. Then here we have another variable B. Inside B, we are storing the int of A. Okay, means we are converting the data type here. And then we are checking the type of B. And if you run this one, you see, sorry. So first A is a string. Okay, and B here is a integer. Okay, where you have converted A here. So this is how we can convert. Same as you can convert in any other data type like float. Okay, for example, let's say we have a list here, list 1. Okay, and let's say we have some values here, 1, 2, 3, 4, 5, like this. And if you check the type of this list 1, so you will see this is list simply. Okay, but if you change this type, let's say list, or let's say A equal. Now here I want to change this list to tuple. So you can simply mention tuple here. Okay, and then you can mention the name of your list, which is list 1. And then again we can check the type of A, which is print the type of A here. And if you run this one, so previously your list, this one is a list, and then we have converted your list into tuple. Now this is a tuple here. Okay, so this A contains tuple. Okay, if you print A, you can check out it is a tuple. Okay, so it is a tuple 1, 2, 3, 4, 5. So this is how we can print the tuples. Sorry, change the data types. Same as you can do this with the tuples, you can do with the set, frozen set, or list, or any other data type. Okay, but you cannot do this one, which is, let's say we have this A equal, and let's say we have any string here, John. And if you are changing this A into any other data type, for example, B equal int of A. Okay, so this is not possible because here we have these characters here, and these characters cannot be converted into numbers. So if you print the B, you will get the error. Okay, you can see invalid literal or data type for int. Means JOHN, you cannot convert this into any number. But if you mention number here, then you can convert simply. Okay, then you can simply run it and you can convert 1. So 1 is an integer here now, not a string. Okay, so this is known as typecasting, which is changing your one data type into another. Let me show you. Typecasting. Okay. Then, yes. Any immutable data type can be converted and convert to mutable, and you can change it, and then you can convert back into any other data type. Okay, like immutable one. Yeah, we cannot change string into any other data type. We cannot do it. Okay. So now let's perform some operations with the input. Okay. Let's say we can perform some arithmetic operation. Okay, like here we have some arithmetic operations, or we can say arithmetic operators. So here we have plus, we have this, minus, we have this multiplication, division, then we have this one second division. Okay, and then we have this modulus and exponential. Okay, so we have these arithmetic operators in Python. So what we can do, we can perform some operations. So we can simply use num1 equal, let me paste here. So here we have this num1 and let me change it to int. Okay, int input. Same as here, int input. So here we are taking first number and second number. And then we can perform multiple operations with the help of arithmetic operators. We have num1 plus num2. Okay, and we can simply copy it and paste here. And here we can just change to minus, multiplication, division, and then modulus, which is percentage sign. And then here we have this exponential. Okay. So here, let me show you. So this will give you output. Let's say we have 2 plus 3, which is 5. Then again, 2 plus 3, which is minus 1. Okay, you know multiplication, which is to multiply 3. Sorry. Okay, now let me show you the output here first. Let me open the terminal here. Yeah, so we can mention the first number, let's say 4 or any other number. Okay, like this. Okay, so here we have this 5 plus minus multiplication and division. Now this first division, okay, so this is a float division. Okay, so this is a float division and this second is an integer division. Okay, now you can see in the float division we are having output 1.5, but in the integer division it is providing only 1 only. Okay, so it is not showing the this decimal values. So that is why it is an integer division. Then with this modulus, modulus always returns the remainder. Okay, remainder part. For example, in this division 1.5 we have the remainder 1 here. Okay, sorry, in this division which is 3 and 2, here we have this remainder 1. Okay, so here we have this remainder 1 here. And then exponential, which means power of. So this is 2, 3 power of 2. Okay, like 3 times 2, so which is 9. Okay, so these are all familiar. Okay, but this is a float division, which will provide you decimal values. And this is simply integer division, which will like not show the decimal value. And this is modulus, which will show the remainder part only. Okay, of the division. So for example, if 4, you are dividing 2, so this will give you 0. Okay, because 4 is completely divisible by 2. So that is why we have like output 0. Okay, so here we can mention 4 and 2. So we have modulus 0 because no remainder. Then we have exponential, which is 4 times 2. Okay, means 4 into 4, 16. So this is how we can use the arithmetic operators, okay, with the input function. Even you can mention any of your test here. For example, if we are taking name equal input, okay, enter your name and same as, okay, here you can print, which is your first name is, okay, and here you can mention, now this is a string, okay, your first name is, Then here you can put comma after your string, and then you can mention the variable name. Same as you can do this with the last name. And here you can change the variable underscore name. Okay, so if you run this one, so your name. Okay, so your first name is Bhavre and second name. Okay, so this is how you can add any of your like string before your like your variable. Okay, there are like some other ways of mentioning your string and your variable together that we will see, like formatting of your strings. Okay, so I think that's it for today. Okay, and you all know what are comments, okay, which is like ignored by your Python interpreter. You can use this one, your hash, or you can also use multi-line comments. Okay, like and here you can mention your comments. Okay, like multi-line comments, anything. So you have single line comments which you can use with the help of hash, and then we have multi-line. You can use triple quotations. And if you want to use shortcut, then you can select and you can use control plus forward slash and comment like this. Okay, same shortcut. So any other questions, any doubts, any queries? So now you can ask. Any questions? Anyone? If not, then we can wrap the session here. Okay. Okay, so no questions. Then we can wrap the session here. And this one more extension, if you want to use, you can click on the extensions, and here you can use black box. Okay, so this is a wonderful extension for give you the suggestions. Okay, this one, black box AI. So you can simply install it. Okay, this is like this will give you like what let's say this will like identify your typing patterns. What kind of like let's say if you are adding two numbers, let's say num1 equal, and here you can use uh let me use name here, name equal, comment this one. Yeah, so let's say here you are using name equal input, and here you are mentioning, let's say, enter your name. Now you can see this your name in gray. So this is like giving the suggestion. Okay, so you can press tab key here. Okay, to auto complete. Same as you can see last name here equal input and enter your. So you can press tab key again. Okay, now you can see this is a suggestion. So if you want this one, you can install this black box AI. It is like this will identify your typing patterns. What are you, whatever you are coding, and this will like simply help you. And you can see it is like helping me to print something. Okay, so this will like a wonderful extension. Black box AI. Okay, this one. So you can use it. Yes. This is simply for the new line. Okay. These are known as escape sequences. So this is simply for the new line. We will discuss tomorrow. Okay. Okay. So now we can wrap the session and the rest we will continue tomorrow. If you have any queries and doubts, then you can ask tomorrow. And I will share this notes file. Okay. This one and this Python file in your group. Okay. In the main group. Thank you.